Hello, good morning, class. In our earlier discussion, I told you that I will be taking you mechanical science, and I briefly told you about the topics we'll be covering in mechanical science. And today, I wanted us to start with our first topic, which is work, power, and energy. They are not new terms. You have learned them again. You have, because all of you have done physics in your high school. These are not new terms. So I know it will be it's a topic for you and you are going to learn more. So we are going to start our topic today by looking at energy. So what is energy? We see that energy is the capacity for doing work and it is measured in joules. So energy exists in various forms. We have the mechanical energy, electrical energy, heat energy, chemical energy, etc. But in our case, we are going to measure ourselves in mechanical energy. And mechanical energy now we'll be looking at two mechanical forms of mechanical energy. This is the potential energy and the kinetic energy. So what is potential energy? This is the energy possessed by a body due to its position in a gravitational field. So when we mean energy possessed by a body due to its position, we are going to refer to two things. First of all, we will refer to the height of the thing above the ground. And then, for example, when we want to lift a body to the same height or want to lift the body from the ground, we say we are doing work because you are lifting this thing from the ground to the position where you want to lift it. So you do work because you are doing against gravitational force. So every time you know that the gravitational force tries to pull things down. So when you are trying to lift something up, you are doing work because you are doing against that gravitational force. So the amount of work done against gravitational force is stored in the body as potential energy by virtue of its position relative to the ground. The body is capable of doing work when it falls to the ground. For example, when we say a body is lifted, energy is transferred to it. That is, potential energy is equal to the mass of the body multiplied by the gravitational force, then the height which you have lifted that body. So another form of mechanical energy is the kinetic energy. And this is the energy possessed by a body by virtue of its mass and velocity. That is, this body must be moving. If the moving body is brought to rest, the energy is meant to do work against the resistance. So if unrestricted force act on a body of mass m, initially at rest, and it displaces it in a straight line through a distance s meters, we see that work done is equal to mass of the body multiplied by the acceleration and then the distance covered. The body attains a velocity v, which is in meters per second. From Newton's equation of motion, which we earlier covered, we see that v squared is equal to u squared plus 2as. V is the final velocity, u is the initial velocity, a is the acceleration, and s is the distance covered. So this we want to equate so that we can get the formula for s. And since now our initial velocity is 0, that's why you have v squared and divided by 2a is equals to s. And that's now our formula for distance. So now, if you replace that s in our initial formula of work, which we said is mass multiplied by acceleration multiplied by distance covered, you replace the s which we have substituted there with v over 2a, you get that work is equal to mv squared divided by 2. So the work done by a body in motion for a given displacement is equal to kinetic energy stored in the body. That means kinetic energy is equal to half mv squared. The work done by the force to set the body in motion is stored in the body in the format of energy. And this is what we have called kinetic energy. Then now what is work? We see that when a force applied on a body makes it to move in the direction of the force, work is done. For a constant force, work done is equal to force multiplied by the distance covered. That means W is equal to Fd. And this work done, we say work is measured in joules. So we can have an example. We can have an example so that we can understand what we are saying. Work done in lifting objects. Find the amount of work done by hydraulic waste in lifting a vehicle of mass 1,500 kgs to a height of 2 meters. So what do you have? Solution. What are you given? First of all, you are given the mass of this hydraulic waste, that is 1,500 kgs, and then you have the height, which is 2 meters. So remember, we have seen that work done is equal to mass multiplied by gravitational force and then by the height. So you have our G, which is 9.1, that is constant. Then you multiply that one now by the distance and you get work done in joules. So class, for today, before we go to principles of energy conservation, we'll leave our lesson at that point. But I can give you an example so that you can go and work on it. There is that example on the board. So please copy that example. An engine has a mass of 150 kilogram and is suspended from a crane by a string 4 meters above the ground. Determine the potential energy of the engine due to its position above the ground. Then number B, due to a fault in the string, the engine falls freely to the ground from that height. Calculate the velocity and the kinetic energy of the engine. So work out that example. When we meet in our next class, we are going to evaluate that one, then we'll continue. Thank you and good day.